Welcome back to the Code and Capital channel. In today's video we're gonna go over backtesting and the Python library that we're gonna use to backtest in future videos. Why should we backtest in the first place? Backtest helps us to simulate a trading strategy on historical data, with the goal to evaluate risk and return before committing real capital into that strategy. It tries to answer the core question: how would this strategy have performed in the past? It helps us therefore to form expectations about future behavior. Backtesting for us provides a structured and disciplined evaluation process of a strategy. It reduces reliance on, and that is a very important point, intuition, anecdotes and emotions. You don't want to be attached to a strategy and run it into the ground. Therefore, it enforces a consistent rule application. It helps us to frame the strategy in a scientific and quantitative process. Why does this matter? We want to evaluate a strategy and those ideas, and we want to avoid mistakes in the future. We want to see what the strategy would have done based on volatility and drawdowns and risk-adjusted metrics such as Sharpe ratios. How are we going to do it here? We're going to implement a backtesting library in Python. It's going to be a very data-driven way using the data that we pulled in the last two videos. If you didn't watch those yet, you should go back and create your own data library first. And we're going to go step by step so that you don't miss any points and you understand the important steps in backtesting. After this video, you will have the confidence that your strategy works. We want you to give some measures so that you can say, this is a strategy I trust in. As always, we start by importing some of the packages that we need later on, such as NumPy and pandas, as well as two handy functions that we wrote around the database that we created in the last two videos to pull pricing and holdings data. In the first step, I pull the holdings out of the S&P 500, and in this video, we just use the top 30 biggest holdings. Then I pull the prices data down here, and we just drop Google out of that sample because there's two Google tickers in the 30 biggest companies. It's GOOG and GOOGL, which are highly correlated. So we're gonna drop one of those. We can plot 6 of the companies and see the prices for those companies over time, starting in 2020 to today's date. Now that we have all the packages installed and all the data loaded into our Python environment, we are ready to finally start the backtesting. We are going to use the BT library. BT is a flexible backtesting library written in Python that is pip installable to your machine. We're going to use a slightly adjusted version of BT. It's very similar, but you can check it out in our GitHub if you want to follow along and use that one as well. You're also fine with just using the BT pip installable library. Why are we going to use BT? BT is a very convenient library that makes it easy for a user to backtest a strategy. We can easily switch in and out algorithm, which I explain in a second, so that our strategy is very, very flexible and you only have to change one line of code to change the weighting algorithm, your strategy, or whatever you want to look into. BT normally starts by defining a strategy. A strategy is a list of different algorithms. There's stuff like flow algorithms, which are, for example, how often do you want to run your backtest, or how often do you want to rebalance your backtest, better said. Would you want to run it daily, monthly, annually, or maybe only once in like a buy and hold setting? Then there's selection algos. Do you want to select every security? Do you want to select every active security? Maybe you even want to randomly choose a security, or you selected where a security is in an index. Next, we can also put stats algos in. That could be moving averages. You could calculate total returns or risk based on which you then select your securities. Then, based on those stats, you can create signals. For example, in future videos, we want to create trend signals, momentum signals, or you could use our fundamental data that we pulled in the last video and create some value signals. You can also add weighting algos. Weighting meaning you could equal weight your portfolio, you can market weight your portfolio, or you can get fancier and do something like inverted volatility portfolios, or even more advanced algorithms like risk parity, HRP, or MVO. Don't worry if you never heard those weighting strategies before. We're gonna create future videos on every single one of those. In the end, after you created your strategy, we can backtest that strategy. You will see in a second that it is very convenient because you can just create a strategy saying, I want to run it monthly, I want to select all securities, and I want to weight them equally. We are going to go over 3 total examples that I want to show you using the BT package. First, we're going to implement a buy and hold strategy out of our 30 names. Next, we're going to do the same, but use a risk parity approach. And then in the end, we get even fancier and combine those 2 strategies into one strategy. So let's start by implementing the buy and hold strategy. And you will see that it is very easy to use, and that's one of those big advantages that we have using BT. If we go back, our first step is to create the strategy object. So we say something like from bt.core import strategy. That is already it, and we can import our strategy. Now if we go back here, now we have to define all the algos that we want to run. So in the following, we want to run, because it's a buy and hold strategy, we want to run it once. So we do from bt.algos.flow import run once. And now we can just say our run algo equals run once, and that's already it. We have our run algo implemented. Now we go in and we want to create our selection algo. We say from bt.algos.selection import, and what we're gonna do is we select every security out of our 30 securities in this example. So we can then say select algo equals select all. Next, if I run that. Next, if we go here, next in line, we don't need stats in that example because we don't want to calculate moving averages, risk returns, or whatever. Next, we're gonna use a weighting algo. So we can say from bt.algos.weighting import, and we want to, in this example, just equal weight them. And we then say our weight algo equals weigh equally. And now we're already there. All we now have to do is introduce our backtest and our strategy object by itself. So lastly, after we do all of that, we obviously want to rebalance our portfolios. So we always have to bt.algo.portfolio.ops import rebalance. So we always have to rebalance our strategy. So we say something like rebalance algo equals rebalance. Very convenient, very easy to use. All we now have to do is create our strategy. So we can say strategy buy and hold equals. So now we call our strategy object. The first argument in the strategy is the name, so we just call it buy and hold. And then the second argument is all the algos we want to run. As I mentioned before in the introduction, algos is a list of all the algos that we defined. So first of all, we want to run it on we only want to run it once because it's a buy and hold strategy. Next, we want to select our securities and we want to weight them equally. And lastly, we want to rebalance the strategy. And that's already it. That is creating our strategy object. Now all we have to do is create the backtest. So we say from bt.engine import backtest. And our backtest equals backtest, and we can just put in the strategy that we just created. So strategy equals strat buy and hold. We can then say the data being the prices that we pulled on top, and we just put integer positions equals false here. So if we run, well, if we create the backtest, and now all we have to do is run our backtest. So we can store the results equals bt.run, and all we have to do is run that backtest. And you can see we created a backtest in 2.29 in less than a second, and yeah, you see it's 2 iterations per second. The nice thing is the results, the outcome of our backtest is an object with that gives you a lot of information about the strategy already. So for example, and we're gonna show you some more in this video as well. So we can say prices buy and hold. You can go to results.backtests, and we can look at, this is now sliced by the name of our strategy. So we can say results on backtest. We go into the strategy, we go into the prices, and we can look at prices buy and hold. And you can see it's a series of the returns of our strategy. So we can now say we want to frame it, and we call it buy and hold. So now we have a nice data frame of the returns of our strategy. Don't worry if this looks a little confusing to you in the beginning. You will get used when we use the BT package more often. So we already backtested our first strategy, and we can now look at the returns of that strategy over time. So you can see the development starting in 2020, going all the way to today's date of that strategy, and you can see that it returned almost went up from $100 to $500 if you would have had it. As mentioned before, BT is very nice because it comes with a lot of pre-calculated statistics that you can use to evaluate your strategy. I just want to show you a couple of them. We go back to our results objects that we just created to run our backtest, and we can do results.stats. And this already gets you to a point where you can see a lot of different metrics for our buy and hold strategy, such as start and end date, max drawdowns, annualized return ratios, Sharpe ratios, and so on. In this video, we're gonna focus on a couple that I pre-selected. We don't need to do that. And we're gonna look at the start and the end date. So we started running our strategy in 2020. It ended with today's date being in 2026. February, and we can see our strategy returned a total return of almost 400% with an annualized return of 30%, a daily volatility and max drawdown ratios of 26 and minus 32%, and a pretty decent Sharpe ratio with a 12 months winning percentage of 85%. I just want to mention it here, and we're gonna go over this in a future video. This is not an actual good backtest because we introduce a lot of biases such as survivorship bias. This is just for the purpose of showing you guys how to use a good backtesting library. We're gonna go over what it needs to run a good backtest in one of the next videos. Another nice thing is we can also, before we do that, let's just say those are our stats buy and hold, so we can compare them later on to our stats of the risk parity strategy, for example. Another nice thing is that we can look at the weights over time. So we're gonna slice back into our results and backtest, and we once again go back to buy and hold, and we can look at the security weights. Security weights now gives you the weights over time for each of our securities. You can see as we selected equal weight, on the first day, all of them are introduced at 3.5714%. And at the end, they're obviously not anymore because we never rebalance, we only buy and hold the strategy. So let me call this df weights. And we can look at the plot over time. So we can see we introduce an equal weight at the beginning, and then at the end our weights disperse a little bit. For example, Nvidia being 22% because of very good recent performance. The next strategy that we want to look into is a risk parity strategy. Risk parity, instead of equal weighting each position in our portfolio, tries to assign an equal amount of risk to each position in the portfolio. It does it by calculating historical correlations and volatilities of the securities. If you've never seen the risk parity approach before, don't worry, we will go over risk parity and as well as some other risk-adjusted weighting schemas in future videos. In this strategy, we want to now equal risk weight the portfolio as well as rebalance it monthly. So we don't want to do the buy and hold that we did before. We now want to rebalance our portfolio monthly. So we need to introduce a new run algo, being import, you already know the algos. We go to flow and we import run monthly. I also mentioned we need it from here. I also mentioned that we need to calculate a historical covariance matrix. To do so, we need to give the algorithm some time to see some data so that we can calculate a stable covariance matrix. So we want to introduce the run after days algo. I'm going to explain that in a second. So let's start by using our run algo, now being run monthly, and the run after days algo. So what the run after days algo is effectively doing, let me do our run after days algo. The run after days algo is effectively waiting for whatever amount of days I give it and then runs the strategy after that day. It blocks the strategy from running before those days are done. So we can pass it a days equals, and we want to wait for 6 times 20. So we want to wait for around 6 times 20, so 6 months, and we add another day for a lag here. We now go in and say we already know the next step, our select algo being select all. And now we introduce our new weighting algo. So we do from bt.algos.weighting, and we want to import weight ERC, equal risk contribution. So our weight algo now being weight ERC, and we want to look our lookback being how many days, months should we wait, should we use in our covariance calculation. So we use pd.dateOfset, and we say we want to wait for 6 times 20 days, as well as adding a lag being 1 day. Days equals 1. And that already is our weighting algo. And now all we have to do is create our rebalance algo again and put it all together into a strategy. We call it strat risk parity, and we already know the syntax for that. We have a strategy object that we call risk parity, and our algos is the list of everything we just created. So we want to first run after days, we want to run monthly, we want to select all, we want to wait based on risk parity, and we want to rebalance our strategy. All we now have to do is create our backtest. So we say backtest, and we want to use our strat RP. We want to use our prices again, and we allow non-integer positions. If we do backtest, and lastly, we create our result object, and then we do that by running our backtest. And that's already it. You already see it ran in under a second again. To look at the results of our backtest, we once again slice into the backtests. We look at risk parity, and we now concatenate with our buy and hold strategy to compare the two strategies. If we run that, we can see that our buy and hold strategy outperformed the risk parity strategy just looking at the plots. And we see, especially in the beginning, our risk parity strategy is flat because we wait for 6 months for it to calculate the first portfolio. We can do something similar to what we did before by looking at the stats, because just looking at a plot might be misleading. We can compare our buy and hold strategy to our risk parity strategy in the table. We see that, yeah, the buy and hold strategy outperforms, but on a risk adjusted return basis, our daily Sharpe here, the risk parity strategy is actually the better strategy. It does it because our daily volatility drops by almost half, and that's the main goal of risk parity, right? It wants to minimize, the main goal is not to minimize volatility, but the overall volatility should be smaller than in a simple buy and hold equal weight strategy. We can once again look at the weights. If we run that, we can see the weight contribution for our risk parity, and we can see that it is more balanced now, and it's not running into a huge position like Nvidia before, because we are rebalancing on a monthly basis. Another nice thing about BT is that we have other statistics that we can look into. For example, the turnover. Turnover being how much do we at each rebalance have to buy and sell out of our portfolio. And if we look at our turnover, we can see that the risk parity strategy normally rebalances between maybe 3 and 6%, something spiking up to 12%. The last strategy that we're going to look into is the combined strategy of our buy and hold and our risk parity. So we basically want to keep the upside of our buy and hold, but we want to minimize the overall volatility by mixing in our risk parity strategy. You can see that we want to basically 50-50 weight the buy and hold strategy and the risk parity strategy. So think about it like we have a top portfolio where we have two sub-portfolios, one being our buy and hold, one being our risk parity strategy. We then want to rebalance those two portfolios monthly by giving them each equal weight. Under our portfolio, in those sub-portfolios, we still keep the same strategies. So the buy and hold strategy will still only be rebalanced at the beginning and never be touched again, whereas the risk parity strategy will also be rebalanced on a monthly basis. If you go back to the code, we can just do that by creating a strats list. A strats list being we create the strats buy and hold and the strats risk parity, which we created before, and store them in a list together. We now, instead of passing in the prices as our children, we now pass in the strategies. We also give it the algos that we want to run. We want to rebalance our portfolio monthly. We want to select all, being both our sub-portfolios, and we want to equally weight them. If I run this backtest, you can see it takes a little bit longer. It takes 2 seconds now, but we can create our prices data frame again, and if we run it, we can now see that we have our buy and hold strategy, our risk parity strategy, and somewhere in the middle, a combination of the two being our combined backtest. If we look at the stats for that one, you can again see it has to lay somewhere in the middle in Sharpe ratios and as well in total returns, which makes total sense. If we just look at the weights based on our sub-portfolios, we can see that it is almost 50-50 between the risk parity and the buy and hold strategy. There's some fluctuation at the beginning because, as you remember, we couldn't create our strategy at the beginning because we have our risk parity strategy, because we have to wait for 6 months for the covariance matrix to calculate in a clean way. But you can see it is very easy to run strategies of strategies, and that's gonna be very convenient for us later on, where we want to, for example, combine a momentum strategy with a mean reversion strategy. We once again covered a lot of ground in this video. You're now able to backtest your own strategies in Python from beginning to end. You can evaluate if your strategy works or not, and if you should go live in production with that strategy and actually put money on it. You can play with all those different parameters. You can switch up your signal from momentum to other trend signals. You can change your weighting schema from risk parity to mean variance optimization, and all those other little levers that you need to create a strategy. We will build on top of those BT frameworks in future videos and actually play around with different strategies and see if they still work in real life settings. Thank you for tuning in.